The current presentation summarizes the work presented in the paper called How an Automated Gesture Imitation Game Can Improve Social Interactions with Teenagers with Autism Spectrum Disorder. The paper was submitted for the workshop on social robotics for neurodevelopmental disorders at ICRA 2020. And this work is part of the thesis that is ongoing with the École Doctorale Polytechnique in Côte d'Ivoire and IMT Atlantique in France. Our table of contents follows the standard IMRAD. In the introduction, we want to present the purpose of the research, which is designing a socio-technical system that will implement a gesture imitation game in order to help improve social interactions with adolescents with ASD in Côte d'Ivoire. Why a socio-technical system? Because human contact provides meaning and significance to otherwise mechanical interactions. Why an imitation game? Because it is an important lever for neurodevelopment. And serious games have appeared to improve imitation and joint attention abilities in children with ASD. Why adolescents with ASD? Well, most related studies focus on children with ASD, and there is a need for studies involving teenagers. The hypotheses tested by our pilot study are: one, induced imitation is possible with a selected set of adolescents with ASD. Two, an artificial intelligence algorithm can be used in a real-life environment to detect the poses of adolescents with ASD. And three, the design scenario allows for the establishment of basic social relationships. Our methods follow. We held preparatory sessions with autism professionals, autistic teenagers, and/or their parents, designed a high-level canvas for the unique intervention that took place in Centre d'aide médico-psychosociale de l'enfant, Asseu, in February 2020. And our base scenario is comprised of 4 phases, including greetings, pairing, imitation, and closing phase, with the movements imitated being arms raised above the head, arms raised left, right, in front, bending over to reach toes, or when imitation without object was not possible with one participant, we used colored balls to perform simple gestures. We had 4 participants in this pilot study, no control group. The participants were 1 female and 3 male, aged 12 to 18 years old, with a neurodevelopmental age comprised between 6 months and 9 years, and a childhood autism rating scale score between 33 and 47. The evaluation criteria for social interactions were head orientation, smiles, laughing, hugging, holding hands. Our base configuration comprised of the participant with ASD, 1 caregiver, a human experimenter, a technical operator, and 2 people recording the scene from different viewpoints. 1 person recording the whole scene, and the other one recording the scene from the experimenter's point of view, which would later on become the social robot's point of view. We planned to use social robots because they can provide a focus of attention that can reveal communicative and social competencies, and they may also help reduce repetitive and stereotyped behaviors. For the pilot study, pose detection was performed using a computer with an internal camera and the open pose algorithm. The work environment is described here in terms of technical specification, and the TensorFlow pose estimation code is available at that link on GitHub. To launch the pose estimator, that last line on the slide has to be used with those specifications in terms of image size and model. Our preliminary results are the following. This table shows that for the different participants, we had scoring for each of the greetings, pairing, and imitation phases. Scores of 3 or 3A, 3B means success. 2 or 2A mean intermediate. The B refers to the recognition of being imitated, and this was assessed in case the participant could not imitate. The last column is a column of comments about the CAR score, the type of imitation with or without objects, and the assessment of the social interaction that was established. As for the pose estimator, those screenshots show that the pose detection was successful in most cases. However, in certain cases, we had pose detection failures. And the main reasons are body occlusion, loose outfits, like the skirt on the second image, insufficient lighting or non-uniform lighting, like on the second and third image. And also the fact that the participant has a 3/4 position. This could also affect pose detection. The initial hypotheses were verified. Induced imitation is possible with a set of adolescents with ASD, as 3 out of 4 participants actually imitated gestures upon request. An artificial intelligence algorithm can be used in a real-life environment to detect the poses of adolescents with ASD. Indeed, pose detection was successful in most cases, and the failures could be explained. The design scenario allows for the establishment of social relationships, which is true, as social relationships could be established with all 4 participants at different degrees, of course. Here is the video link to the session. Discussion. The pilot study allowed to verify initial hypotheses. It shall be possible to use the pose estimator algorithm within the framework of an imitation game for adolescents with ASD. Some important environment settings are to be taken into account, as we saw earlier. The full game algorithm is currently being developed and will be implemented on a social robot, which will be chosen based on a comparative analysis that is ongoing. As future work, we plan to have more regular sessions with a higher number of participants, at least 20, plus a control group, duration of protocol higher than 6 months, be able to assess induced imitation, spontaneous imitation, as well as the recognition of being imitated, and have, of course, a patient-carer robot configuration where the gesture recognition will be performed using a robot with a camera and a full game algorithm. Thanks for your attention. Here are our references.